Hello grade 9 American System, this is Mrs. Nancy. Today I'm going to start a new section 7.3, Bonding in Metals. The objectives of this section are model the valence electrons of metal atoms and explain the importance of alloys. So please open your books page 209. Metals consist of closely packed cations and loosely held valence electrons rather than neutral atoms. So, the valence electrons of atoms in a pure metal can be modeled as a sea of electrons, meaning the valence electrons are mobile and can drift freely from one part of the metal to another. So, metallic bonds are the forces of attraction between the free-floating valence electrons and the positively charged metal ions. These bonds hold metals together. Properties of metals. Metals are good conductors of electric current because electrons can flow freely in the metal. So as electrons enter one end of a bar of metal, an equal number of electrons leaves the other end. Also, metals are ductile, meaning they can be drawn into wires, and metals are also malleable, meaning they can be hammered or pressed into shapes. Alloys. First, let's define alloys. Alloys are mixtures of two or more elements, at least one of which is a metal. Brass, for example, is an alloy of copper and zinc. Alloys are important because their properties are often superior to those of their component elements. For example, sterling silver is harder and more durable than pure silver, yet is still soft enough to be made into jewelry and tableware. Also, bronze is an alloy containing 7 parts copper to 1 part tin. Bronze is harder than copper and is easier to cast into molds. The most important alloys today are steels. Alloys. The principal elements in most steels are iron, carbon, boron, chromium, manganese, molybdenum, nickel, tungsten, and vanadium. Alloys have some useful properties such as corrosion resistance, ductility, hardness, and toughness.